My name is Nick Hill. This is Andy. We're both heads of product on the Amazon FSX team. And we also have the pleasure of being joined later on in our session by Mani Madhunapuntula from Arcesium, who will tell us a little bit about his customer experience with Amazon FSX. So we're here today to talk about meeting performance demands for business-critical applications with Amazon FSX. And before we get started, we've introduced the speakers. I was hoping to learn a little bit more about the audience. With a quick show of hands, can folks who are building or managing an application that they consider to be business critical for their company, please raise their hand? All right. And is there anyone here who is aware of or familiar with the Amazon FSX services? Awesome. Is anyone actually using Amazon FSX in production? Okay, great. All right, so it looks like we have a good mix of folks. Hopefully we'll have some part of our presentation that's suitable for everyone. So to begin with, what do we mean by business critical? Well, to begin with, business critical applications are ones for which it is truly essential that they stay running on a day-to-day basis or a minute-to-minute basis. So these might be things like core databases or data stores that power the backbone of your IT organization. They might be core apps like a HCM or ERP or a CRM that your employees rely on for their productivity. Or there might be critical parts of a customer-facing product or service that your customers interact with all the time. And for business-critical apps, of course, it's essential to minimize downtime and prevent outages, because any such disruptions can be very painful and they can be very costly to your business. And if any disruptions do arise, it's really important that these applications sit on resilient architectures so they can recover in a way that's fast and effortless and minimizes the impact to the end users or processes that might be relying on the applications. So a few examples of some business applications. These really span almost any type of application environment or industry that you might think of. Here are a few examples, some of which we'll be diving into today in more detail. And we have customers running each of these and more, and each one is business critical for their company. Now, one of the interesting things about these applications is really how varied they are. For example, if you're running a semiconductor design workload, say you're an EDA, you're facing an entirely different set of application performance requirements, availability requirements, constraints than, for example, a financial risk management system that's running fraud detection on financial transactions. And even within an application category, you might have different application vendors, you might have something home-built, entirely different sets of customizations that make application needs very varied. And yet, we see that regardless of what type of business critical applications a customer might be running, we see that almost all customers running business critical applications are looking to move these applications to the cloud. And that's really because the cloud can provide three key benefits for these types of applications. First, customers know that the cloud can help them improve resiliency and avoid business disruption. And as we've just heard, this is really table stakes for these types of applications. Second, customers know that the cloud helps them ensure high performance for their applications, even as their performance needs evolve over time. And this is super important because most of the applications that we talked about have performance demands that do vary over time or need to grow and scale as the business scales. And third, the cloud helps these customers manage costs, and in a way that doesn't sacrifice performance or agility. Even for business-critical applications, customers want to make sure they're benefiting from efficiencies wherever possible. They want to right-size all the resources they're using. They want to avoid over-provisioning or overpaying. But again, without needing to sacrifice app performance. So these customers are looking to move their applications to the cloud to unlock these few benefits that the cloud provides. Now, what we know, however, is that one of the challenges that customers can face is moving their application's storage layer. Almost every app relies on data storage. And what's more, often applications are built, often having specific assumptions about the type of storage solution that they're built on. For example, many solutions have been developed over decades in conjunction with specific types of storage, such as file systems. And these file systems might offer unique capabilities, things like specific data access features, things like performance profiles or typical performance for application requests, or data management APIs that the applications rely on. And if these customers were just to move these applications to, say, a general purpose cloud storage, that process might take months or even years. And that's because these customers might need to do things like re-architecting these applications for the different storage solution they sit on. They might need to recertify that the application actually works as expected. And they might need to retrain application admins or application end users on how to run the application and anything that might have changed in the new environment. And what's worse, they might even need to give up some of the data capabilities or enterprise features that they had in their on-prem storage solution.
So, these challenges that Nikhil mentioned, we've been working with customers for several years now to migrate and move a lot of these business critical applications over to AWS. And this is a challenge that we've heard from a number of customers over the years. To address this challenge, about 5 years ago, reInvent 2018, we launched a family of storage services at Amazon called Amazon FSX. For those of you who aren't familiar with FSX, FSX, it's a little bit of a play on words. The service name itself stands for File System X, X like a variable in middle school algebra. And the idea behind this service is, as Nikhil mentioned, there are a number of different file system and storage solutions that customers use to power their applications. There's no one-size-fits-all that we see. And our goal with Amazon FSX is to give customers a choice when they're coming to the cloud. If there's a specific application you're running that depends on, or that you're used to running on a specific storage solution, and you may have a different application that uses a different storage solution. Our goal with Amazon FSX is to give you that same choice in the cloud, to continue having either storage solutions that you're familiar with or storage solutions that meet the different performance and price and capability requirements of your different workloads. So what do we mean by your choice? So with FSX, the high-level product model of this family of services is what we do is we enable customers to launch and run and scale fully featured, high-performance, and cost-effective storage that's powered by some of the world's most popular file system technologies. We offer 4 file systems today under the Amazon FSX umbrella, powered by NetApp ONTAP, Windows File Server, OpenZFS, and Lustre. These are 4 very commonly used file system technologies that, based on the customers we've engaged with over the years, customers are commonly using to power a myriad of different workloads. And our goal with FSX is what we do is we give customers the choice to click a few buttons and launch a fully featured, fully managed ONTAP file system or Windows file system or OpenZFS file system. And in doing so, our goal with FSX is to make it easy for customers to do this migration, to leverage the capabilities the cloud enables, the added agility, the flexibility, the high resiliency, all of those benefits that customers are looking to achieve as part of migrating applications over to AWS. Our goal with FSX is to make that migration as easy as possible by offering a storage solution that is powered by the exact same storage technologies customers are used to, making it easy to migrate over to AWS without needing to re-architect, recertify, reinvent data management from scratch. And when we talk about migrations, I talked about 4 different file systems on the previous slide. When we talk about specifically business critical applications and those types of workloads customers are migrating over, there's really 3 offerings within the FSX umbrella, FSX ONTAP, Windows, and ZFS, that we see customers most commonly using for these business critical workloads as part of the migrating over to AWS. So for the rest of this presentation, we're going to focus specifically on some of the patterns that we're seeing with these use cases and some of the workloads that customers are running. When we talk about like-for-like capabilities, I want to share an interesting We put this word cloud together actually in a previous year, but it remains relevant even to this day. When we talk about like for like, when we talk to customers about the different storage technologies they're using, our goal here, and this is an example of with our FSX for ONTAP service, the different capabilities that we provide as part of the service. And the short story is there's a lot of rich capabilities, specifically in ONTAP, for those of you who aren't familiar with it, that make ONTAP a great solution for a number of workloads. It's a very feature-rich file system solution, and our goal with FSX for ONTAP, as an example, is to give customers these exact same wide spectrum of capabilities and features in the cloud, so that if you're, again, used to running on a specific storage solution, you get something in the cloud that works the exact same way.
So we've seen how Amazon FSX provides like-for-like storage that makes it easy to migrate. But once your apps are in the cloud, Amazon FSX really helps to deliver on those benefits we talked about earlier. So remember the three things that app owners are looking for in benefiting from the cloud. Improving resiliency, ensuring high performance that scales with their application, and managing costs. Well, Amazon FSX can help deliver against these benefits. And we'll talk about some very specific workloads and application types, and you'll see how some of the features and capabilities of Amazon FSX can be used to set up your application to achieve these benefits. First, you can improve your resiliency with features like built-in multi-AZ support that provides shared storage that spans across availability zones. You can also use built-in data replication features to achieve cross-AZ or even cross-region replication. And you can ensure fast and flexible recoveries with features like point-in-time snapshots and snapshot restores. Second, to ensure high performance, Amazon provides leading-edge performance scalability. We're built on some of the latest AWS innovations across compute and storage and networking, and we can meet the needs of some of the most demanding applications. And you can scale up and down the performance of your file system within minutes, helping you scale and right-size your file system as your application demands change. And then finally, Amazon FSX provides a range of cost optimization features. And these are not just the file storage specific features, things you might be familiar with like data deduplication or compression that help you minimize your storage footprint. We'll also see in some of the examples we're going to talk through how some of the architectural unlocks that FSX provides helps you optimize costs actually across your entire architecture, both the application layer and the storage layer. So let's dive into a few examples of business critical applications. And we picked these examples because they are pretty commonly used, and it gives an opportunity to dive a little bit deeper in some of the technical requirements of the application. But if you are running an application type we don't discuss, but you'd like to learn more, please reach out to us or come chat with us after. We're happy to talk about how Amazon FSX might be a good fit for your application type. So we're going to talk about both clustered database workloads as well as virtual machine data stores. And to begin with, we'll talk about clustered database workloads, where you have multiple database instances that power the type of high availability requirements that these business critical apps need. And we're going to talk through three examples. We're going to talk through SQL Server, Oracle, and SAP. So first, let's look at SQL Server. Before we dive into this architecture, we're going to use the example of SQL Server with FSX for Windows, but we have a lot of customers, for example, who are running SQL Server on FSX for ONTAP. Once you get into the details and you understand your specific requirements, we can share more details about how your experience might be different on these two services. But for what I'm going to present today, these are benefits you'll see across FSX for Windows or FSX for ONTAP. So in terms of SQL Server, if you're not familiar, SQL Server provides actually a set of features under this umbrella of what's called SQL Server Always On to enable high availability for database deployments. And there are two different deployments options. There's Always On Availability Groups, or AG, and there's Always On Failover Cluster Instances, or FCI. And the basic high-level difference is that with AG, you have multiple SQL Server instances, each with their own local storage. Whereas with FCI, you have a single SQL Server installation that spans across nodes, typically in different availability zones. And it uses a technology called Windows Server Failover Clustering in order to provide that high availability for the entire database application. And you have a shared storage layer underneath that. And it's this shared storage layer where Amazon FSX really comes in. Because typically with, for example, on-premise storage, you could only provide high availability within a specific data site or data center because there was no local storage solution underneath each database node that could replicate synchronously across sites. You might be able to achieve things like a disaster recovery across sites, but you didn't have a true high availability. However, with Amazon FSX, you can actually achieve true high availability across sites. And that's because Amazon FSX has a native multi-AZ deployment type. Multi-AZ deployment type means that file requests are synchronously replicated across AZs between a primary and a standby file server that sits in two different availability zones. And the two different file servers, in the event of a disruption or an outage, the multi-AZ file system automatically fails over from the primary to the standby and back to the primary, ensuring you have continuous uptime for your storage layer. So this allows you to drastically simplify your high availability setups and to eliminate a lot of the manual replication, such as database log level replication, that you would otherwise need to do because you have that built-in instance level protection with Amazon FSX. Now, in addition to being able to build simple and resilient deployments, with SQL Server on Amazon FSX, you also get those other benefits I mentioned around optimizing performance and optimizing costs. On the performance side, FSX for Windows a few months ago actually announced a pretty significant set of performance scalability improvements, which allow you to drive up to 400,000 IOPS and up to 12 gigabytes per second of I/O to a single file system. Actually, our Microsoft Workloads and AWS team just ran some pretty exciting database benchmarking that show how you can drive up to 2 million transactions per minute with a very low cost per transaction on a single file system. And because you can scale up and down those I/O resources on your file system at any time, you can make sure you're optimizing performance even as your database workloads change over time. And on the cost side, first, using SQL Server in the FCI deployment mode, the failover cluster instances, can enable you to benefit from license cost savings because you can use FCI with SQL Standard instead of needing SQL Enterprise. And that enables you to save up to as much as 60% on licensing costs. And besides licensing, one of the things I alluded to before is by actually decoupling the application layer and the storage layer, in this case having the detached shared storage on FSX, allows you to optimize your performance needs independently. So because that replication is taken care of by the FSX file system, you can actually independently tune your SQL Server nodes. And our customers find that they can often achieve the same performance with less memory, less compute, less networking resources for their application nodes, again helping them save significant amounts of money. For example, Change Healthcare is a leading healthcare technology company that's pioneering some approaches in value-based healthcare. And Change Healthcare faced the challenge of migrating a large, high-performance SQL Server deployment to the cloud, while also meeting some pretty stringent high availability requirements. And with Amazon FSX, Change Healthcare was able to achieve all three benefits we talked about. They used multi-AZ storage and failover cluster instances to give them that high availability benefit. They used the high performance of their Amazon FSX file systems to deliver, in their case, consistent tens of thousands of IOPS across their SQL Server nodes powered by a single file system. And by leveraging SQL Server Standard, they were able to save more than $3 million in licensing costs. So that's our first example of SQL Server. I'm also going to talk about clustered Oracle workloads. So these are Oracle deployments such as Oracle Data Guard or Oracle RAC. And for these types of applications, again, we're going to use the example of one of the FSX file system types, in this case, FSX for OpenZFS. And FSX for OpenZFS provides that fully managed file storage, and it's built on the popular OpenZFS file system type. And one of the benefits of FSX for OpenZFS is it offers that rich set of ZFS-powered capabilities, including things like point-in-time snapshots, in-place data cloning, on-demand data replication. And remember in the beginning I talked about how improving resiliency is not just about preventing downtime, ensuring high availability, but if disruptions do happen, you want to have a resilient architecture. You want to be able to recover quickly and seamlessly. And you can use some of these capabilities for FSX for OpenZFS to achieve these objectives for your Oracle databases. For example, FSX for OpenZFS snapshots are application or database consistent. They're also incremental, which means they consume zero space. They can be taken very quickly. They can be taken very frequently. And any snapshot can also be converted into a clone, which can be split from its parent snapshot, and it can be promoted to an independent volume. And this enables you to really achieve new levels of flexibility in terms of your recovery workloads. For example, if you are running you need to run a script and you don't want to run it against your production database, you can build a workflow where you take a snapshot, you promote it to a clone, you run the script on your clone database, and you can separately promote that to a clone volume. And you can run that operation against your production subsequently after you run tests on your clone. And what's more, at reInvent, just yesterday, in fact, we launched a further improvement for FSX for OpenZFS's capabilities. And now FSX for OpenZFS supports on-demand data replication, not just to a new volume within a file system, but actually across file systems. So using this feature, customers can actually efficiently and easily transfer those point-in-time snapshots that I mentioned to their volumes on different file systems. So previously, if your workload involved replicating to a new volume within the file system, you can actually do that now across file systems, enabling things, for example, like greater isolation between production and development environments. So developers can work with production data without impacting the production environment. So again, benefits that really help you achieve new levels of resiliency for these critical, business-critical database workloads. And finally, in terms of performance on FSX for OpenZFS, because FSX for OpenZFS provides a lot of those data capabilities of VSS, it's extremely fast. So it offers SSD storage with consistent latencies as low as a few hundred microseconds, and that's for first byte latencies. You can benefit from things like ZFS and file server level caching for even higher performance levels. And FSX for OpenZFS file systems can deliver up to 1 million IOPS and 21 gigabytes a second of I/O performance when accessing data that's cached on the file server. So overall, you're able to support some of the highest performance Oracle workloads, and you can benefit from built-in ZFS capabilities, things like data compression, to actually further improve your I/O efficiency.
So Nikhil just talked about two workloads where we commonly see customers migrating business applications, business-critical applications over to the cloud, SQL Server and Oracle. And I want to talk about one more database application that we're commonly seeing customers adopt, which is SAP HANA. So as Nikhil talked about with OpenZFS, and a lot of those same benefits are true with our FSX for ONTAP service, file system snapshots and clones are a really powerful capability. Out of curiosity, quick show of hands, how many folks here are familiar with inline snapshots as a storage feature? Right, not too many hands, which is great. This is a 300 level course, going to give you a really quick crash course into what a snapshot is. So without snapshots, what a lot of customers with workloads like this do, if they want to have another copy of their data, is what they'll do is they'll copy the data. That might mean you take your database offline for a short period of time. You take those bytes, you copy them from wherever your storage location is into another location. And then if you ever need to restore, you need to copy the data back from that secondary location into your primary storage. What a snapshot allows you to do is you can basically click a button on your storage system and create in that storage system inline a view of the data that existed in your volume at that point in time without needing to copy any data. At a high level, the way it works is the data basically gets locked when you create a snapshot at a given point in time. Whatever blocks were physically stored on disk get locked. Any new changes you make to your file system since then are tracked separately. But because those blocks are locked whenever you create a snapshot, if you ever want to restore your volume back to that state that your file system was in, that your volume was in when you took the snapshot, there's no data copying that needs to occur. All the blocks that are needed to reconstitute your volume at that point in time that you took the snapshot, they're already there. And what that means for a lot of these use cases, again, Oracle is one example, SAP HANA is another one, is if you ever need to have a second copy of your data to fall back onto for any reason, and we're talking not for DR scenarios, but maybe in a case where you accidentally dropped a table, or you want to have a second copy of your data before you perform an upgrade just to make sure you can roll back. Leveraging snapshots to achieve this goal allows customers to reduce their overall time to do these activities by sometimes orders of magnitude. I'll give you one example. The time it takes to create a second copy of a 6 terabyte SAP HANA database. Using FSX ONTAP snapshots, this takes about 2 minutes. And 90+% of this time is human time. It's the time to go to the console, open it up, click the button. A snapshot itself takes less than a second to create, less than a second to restore. With an offline data copy, and again, this scales with the size of the database. So the larger the database, the longer it takes to do an offline copy. This can take upwards of 30 minutes or even more, depending on the size of the database. And what this means is that, for example, a lot of the customers we engage with who are running SAP HANA or workloads like it, a common practice they'll do is before any maintenance activity, before a patch, you'll want to have a second copy of your database just in case, so that you can roll back to it if something odd occurs during that upgrade. And likewise, maybe you'd want to take a backup of your data once the upgrade's complete, just so you have a clean kind of space to roll back to if you ever need to. By leveraging snapshots to create this view of your database, both before and after an upgrade, this enables customers to reduce their overall upgrade duration by potentially hours. So to give you an example, if you have a database where you start your downtime, you shut off the database, and the first thing you have to do is run a 30-minute backup before you can do any maintenance. And then once the maintenance is done, you also want to take another backup. That's an hour of time you're spending with your database down, unavailable, where you're not actually performing maintenance activities. And again, if you're just creating a snapshot during both of those periods of time, that allows you to significantly reduce the time that maintenance takes. The other place where we see snapshots commonly used is to recover from unplanned failures. Again, a user accidentally dropped a table. These kinds of, what we call logical corruption, these kinds of events occur, and customers want an ability to easily and quickly recover from these cases. And same thing, if customers are periodically taking backups, offline copies of data, the time to restore from that backup could potentially be tens of minutes or hours. But what a lot of customers can do with snapshots is you create a snapshot every few minutes, recovering to that snapshot takes no time at all. The longest period of time is the person going in, figuring out what snapshot they want to recover from, and clicking the button to do so. So it's a really powerful capability that some of the customers we engage with are very familiar with and depend on to meet their RTO and RPO needs. But a really exciting part of bringing really powerful storage technologies like ONTAP and like OpenZFS to customers as part of FSX is giving some of these really powerful capabilities, putting them in customers' hands so that you can leverage from the RTO and the RPO benefits that they provide. I'll give you one example. This is a direct quote we got from one of our customers. I'm not going to read it out loud, but it speaks to just how quickly they're able to do all of these recovery and restore operations by leveraging snapshots. And this is compared to multiple hours if they didn't have snapshots. So one other thing that, another common pattern we're seeing is file systems provide shared storage. And especially for large-scale applications, very often you have multiple database nodes, multiple compute servers that are accessing the same data. And what this means is shared storage provides really exciting capabilities and options in terms of recovery. So as an example, SAP HANA offers a scale-out mode. There's a feature called host auto failover that's built into SAP HANA that relies on having shared storage. And at a high level, the way that it works is you can have standby nodes, so the orange node all the way in the top right, that in the event, let's say that you have an instance failure of one of your worker nodes, the HANA application can automatically detect this condition, can automatically promote a standby host to be an active worker. And because the file system is shared and can be accessed from any compute instance within your VPC at any time, there's no complicated copying of data or remounting really required in this recovery. And the HANA application can do this automatically. So this is an interesting capability. We're seeing customers adopt it that allows you to have a zero-touch recovery process in the event that you have individual instance failures. And again, it's enabled by the fact that the storage is shared and can be simultaneously mounted from multiple compute instances at the same time. So one other thing I want to talk about is, the previous slide I talked about how can you achieve high availability within a single availability zone. So protect against, for example, an instance becoming unavailable. Well, a common thing that we see customers adopt and what we recommend customers do when they bring business critical applications over to the cloud is to deploy those applications in a multi-Z configuration. So this is a configuration where the application, and therefore the data that it relies on as well, is highly available and durable across multiple availability zones, so that you can withstand a single availability zone being temporarily unavailable and continue running your application. So to give you an example of how customers do this with FSX using SAP HANA as an example, so first thing customers can do is FSX for ONTAP supports a capability called Snap Mirror, which is an ONTAP feature that basically allows you to mirror snapshots from one ONTAP system to another. And so what customers can do is, let's say a customer is running a production workload of SAP HANA in availability zone 1 on the left-hand side. What customers will commonly do is they'll create a second FSX file system in a second availability zone, and they'll set up this automatic snap mirror replication between them. Note, this replication is done completely at the storage layer. There's no need for the HANA nodes to move any data around. So the HANA nodes are just, the production nodes are running directly to the file system that's in the same AZ as them, and the storage system itself is replicating its data over periodically. This can be done up to every minute, 5 minutes, 10 minutes, depends on how you want to configure your system. Now, in addition to this, Nikhil talked earlier about how native multi-AZ file systems enable SQL Server FCI deployments and make those easy to deploy in AWS. Similarly, a common pattern that we see customers adopt for SAP HANA is customers will store their log backups on a multi-AZ FSX for ONTAP file system. So these HANA log backups, they're written periodically. Customers can define at what frequency they're written. I think the default is 15 minutes, but you can make it much shorter than that if you'd like to. And by having these log backups written to a multi-AZ file system, what that means is that those log backups are synchronously replicated between those two availability zones whenever they're written to a file system. What this enables customers to do, I know there's quite a lot going on here, but again, when it comes to a business having high availability, a lot of these features really matter for customers. What this enables customers to do is to have a highly resilient multi-AZ architecture where, let's say there's an event that requires a customer to fail over from one AZ to another. What they can do is, because at the storage layer, their data is being replicated periodically from one AZ to another, customers have another copy of their data in that secondary AZ. And that data may be, again, if it's every 5 minutes, if it's every 10 minutes that those snapshots are being replicated, that data could be up to 5 minutes, 10 minutes old. What a customer can do then is, because these log backups are synchronously replicated across AZs, in the event that you need to fail over to that second AZ, what customers will do is they'll remap, they'll launch compute nodes in the second AZ, they'll map that FSX file system with the data volumes in the second AZ, and then they can replay log backups to catch their database nodes up to whatever the latest state was when those log backups were written. And so again, we're combining a few different concepts here, but at a very high level, what customers can do with this configuration is achieve automatic replication across availability zones without having to do it at the HANA level. And by leveraging a multi-AZ file system for the log backups, you have the ability to replay logs at any time and know that any log backups that you wrote that you flushed are going to be available no matter which AZ you need to fail over to. So this is kind of an example of combining some of these elements that we talked about earlier, both snapshots as well as native multi-AZ file systems. And for those of you who are interested, we actually have a workshop that we're running, I think in about an hour or two, specifically focused on some of these concepts. So we talked a lot about databases, and I want to spend a couple minutes now talking about VM data stores as another example use case where we see customers commonly looking to migrate business-critical apps over. Quick show of hands, how many of you have a VMware-based environment today? OK, quite a number of folks here. So with VMware environments, when we talk to customers looking to migrate a lot of these environments over to AWS, a common theme that we're hearing is customers are looking to benefit from the added flexibility that AWS provides. Flexibility on the compute side, on the performance side, and on the storage side, just giving customers more agility to deploy their infrastructure exactly how they need it to. A few years back, with VMware Cloud on AWS offered what we called a hyper-converged infrastructure deployment. What this means is that all of the VMware compute nodes that you could deploy had storage built into them. So when you would buy compute or RAM or storage, those would all come as one building block. And some of the challenges that we saw with customers looking to deploy VMware, again, this is several years back, was around the fact that by having hyper-converged infrastructure, customers basically, unless they had exactly the same ratio of compute to memory to storage as what the hardware provided, customers were typically overpaying for one of them and under constrained on the other. And this made it difficult for customers to sometimes migrate over. A lot of the customers we talked to actually use shared storage, don't have hyperconverged deployments on-prem, and we're looking for something a bit more familiar. So to give you an example of why hyperconverged has historically been a challenge, let's say a customer has let's say the EC2 hosts offered by VMware Cloud is a certain ratio of RAM to cores to storage. And the virtual machines you're looking to deploy in the hardware happens to have the exact same ratio. In this case, great. You can fully saturate all of the resources of your hardware by placing all your VMs on these servers. This is a best case scenario. What if, for example, you have a storage-heavy workload? So this is a workload where you have more storage per core or more storage per gigabyte of RAM than what your hardware provides. Well, what this means is either you're filling up your server only halfway on compute and memory, or realistically, to meet your entire workload needs, you'd have to deploy 2 VMware servers. And one of them would basically not have, you wouldn't be benefiting from the added CPU and RAM capabilities of that second server that you were deploying. So just last year, to address some of this challenge, and again, this can get very costly because now you're provisioning servers, but you're not leveraging all the capabilities that the servers provide. So just last year, we've been collaborating with the VMware team to launch an integration between VMware Cloud and FSX for ONTAP that allows customers to use FSX for ONTAP as a data store for VMware datasets. So in short, if I go back to the previous slide, what this would enable a customer to do is to have a VMware hyperconverged server for that left-hand side. Have a server with storage and memory and CPU all built in, and place many of the VMs there. But for any excess storage, so for customers who had storage-heavy VMware environments, what customers could do is rather than provision entirely additional VMware compute nodes just for storage, customers could instead create an FSX system and use that storage system to host any excess storage that would have otherwise required them to over-provision on compute or memory. And so one thing I wanted to share is, for those of you who have been following along, about a year ago we launched this integration. And the way that it worked at a high level is customers would create a VMware data store in a VMware account, and then they would create an FSX file system in their own account. And in order for the VMware data store to communicate with the FSX file system, what customers would do is provision a VMware Transit Connect gateway, or Transit Gateway. And this worked great. We have a number of customers who've adopted this deployment model. One of the challenges we've seen, however, is with Transit Gateway, there's a 2 cent per gigabyte data transfer cost. So what this meant is, especially for workloads that were higher performance, customers had to pay to read or to write data between their VMware data stores and their file systems. And so how do we make this better? Well, just earlier this month, VMware announced a new capability which allows customers to bridge their VMware environments and FSX using VPC Peering, which really the main difference between VPC Peering and Transit Gateway for the purpose of this dialogue is that there's no data transfer cost with VPC Peering. So what this enables customers to do is to have a much lower cost point if they wanted to leverage VMware Cloud with independent storage. And the cost savings are pretty significant. This is actually a real customer example we worked with who is looking to migrate about 2,000 VMs over to VMware Cloud on AWS. And what the two leftmost columns on this slide show you is there's two different server options available on VMware Cloud, an i4i and an i3en. And each of these have different amounts of storage, different ratios of storage to RAM to CPU. And for this customer, using a combination of these i4i instances that have less storage capacity per core and supplementing that with FSX for ONTAP, what this customer was able to do is achieve up to a 54% cost savings relative to some of the other options that they were looking at on VMware Cloud. And again, this all comes down to really optimizing and making sure customers are provisioning just the right amount of CPU, RAM, and storage that they need. So with that, just as a quick summary, there's a number of business critical applications that we see across different industries. We spent a lot of time in this session talking about databases and VMware, just because these are common applications that we engage with customers with on a daily basis. They span across a number of verticals. There's also a number of business critical apps that are specific to different industries. I'm not going to go specifically into each of these in this presentation, but very open for if you have any questions or you want to stop by and chat with us afterwards. Again, we're very commonly engaging with customers about similar design discussions when it comes to these types of vertical-focused workloads as well. So with that said, at this point, I would love to invite on stage Mani from Arcesium, as well as Nikhil, to talk a little bit more about Arcesium's journey leveraging FSX for some of their business-critical applications.
Hey, Mani. Welcome. Hey. Thanks for joining us.
Thank you for having me.
So we just heard about lots of different applications that might benefit from Amazon FSX, and we're really lucky to have you here. I know Arcesium has been a longtime customer of Amazon for FSX. So we'll get into some of the details of what your challenges are and how you're using the service. But to begin with, tell us a little bit about yourself. What is Arcesium? What do you do at Arcesium?
Cool. Let's first talk about Arcesium. Arcesium is founded with a bold mission. That's to power the entire investment life cycle. We do it with our data, operations, and analytics SaaS platform. We manage over $675 billion of assets on our platform. We cater to hedge funds, private market investors, institutional asset managers, and a variety of clients. We cater to some of the world's most sophisticated asset managers and financial services institutions. We are a global company. We have our offices in the US, Europe, and India. We pride in our ability to hire exceptional talent. We have over 1,900 plus employees in our global offices. Coming to me, I'm Manikantan, Senior Vice President at Arcesium. I've had the privilege of leading diverse teams and contributing significantly to the tech part of our organization. I have over 17 plus years of experience in the fintech domain. As of now, I manage two critical functions for Arcesium: databases and site reliability engineering. As head of databases, I'm responsible for shaping the strategic vision and making sure that our databases scale and perform, and of course optimizing costs of our database infrastructure. As the leader of site reliability engineering, I'm responsible for ensuring and enhancing the efficiency, scalability, reliability, and observability of our platform. I'm deeply passionate about driving innovation in databases and site reliability engineering realms. I'm again thrilled to be here and looking forward to a discussion.
Awesome. Well, we're grateful to have your experience as part of this discussion. So let's dive into it. Can you tell me about maybe some of the challenges that you are facing at your business?
Sure. Our journey started in 2015, and we experienced substantial growth. In a period of 8 years, assets on our platform increased by 1,588%. Well, with that sort of increase, we had to manage terabytes of transactional data and petabytes of historical data. Naturally, the storage footprint significantly increased, and we had to optimize storage costs. That's our first goal. Next, as part of our RCCM platform offering, we extend the option of staging environments to our clients. Some clients even have multiple staging environments. Having multiple staging environments allows them to run multiple projects simultaneously. Taking an example, they could be running systems integration in one staging environment, or they could be testing upgrade to an accounting system in the other staging environment. Now, these staging environments are created through platform refreshes. So, with increase in data, the time, effort, and complexity needed for platform refreshes also increased significantly. And as a result, our second challenge is to optimize the performance of these platform refreshes. So we started looking for solutions, to optimize refreshes and to save our storage costs.
Yep. Sounds very familiar. Focus on costs, focus on performance as requirements grow and evolve. So what sort of solutions did you look at, and how did you come across FSX for ONTAP?
Well, we started with these two goals, right? Optimizing costs and improving performance. Let's first talk about optimizing storage costs. At RCCM, we deploy a variety of databases. So we use SQL Server, we use PostgreSQL, we use Aurora PostgreSQL. Depending on the use case, we use the most suitable database. So for this discussion, the databases that we operate on EC2 plus EBS infrastructure are the most relevant, databases. In terms of solutions we explored, for EBS, we did the usual and obvious stuff, which is look at unused volumes. We looked at the volume types. We adjusted throughput, IOPS. We looked at snapshots. We trimmed unnecessary snapshots. And we also migrated from GPT to GP3 wherever it made sense. And we also used instant storage for our ephemeral data use cases. All of this helped, but we still saw opportunity to save more costs. Next, moving on to our other goal, which is about our platform refreshes. What platform refreshes need is a fast, consistent, point-in-time, performant copy of databases. So we started with traditional backup restore. We used VSS snapshot, and then we copied our files. We then moved on to using EBS snapshots plus fast snapshot restore. Back in the day, it was called accelerated snapshots. Right, it did help for quite some time, but as our volumes grow, the refresh rate of 1 TB per hour, it became a bottleneck. Yep. Especially for clients with multiple staging environments, the problem was clearly evident. So we started looking for more solutions, and that's where we started looking into FSX ONTAP.
Yeah. So tell us a little bit about your experience with FSX ONTAP. What sort of benefits did you see it providing?
Well, for starters, FSXN is a managed service, so it was really easy for us to get started. Right? We didn't really have to worry about provisioning servers or worrying about detecting hardware failures or installation and patching. After that, we were really interested in the data efficiency features, like compression, compaction, and deduplication. So we created a test plan, we got various data sets, and we started testing compression feature first. And depending on the data that we had, we got about 30% to 60% compression, and we were really happy with it. We also played around with the default compression, and Z standard and default worked well for us. Once the compression part is sorted out, we also wanted to make sure that the latencies are good for our read and write workloads. So we worked with read-only workloads, we tried with read-write, and we managed to get some millisecond latencies in all these cases. So once we're happy with compression and latencies, then we started exploring flex clones. And they've been a game changer, right? They enabled us to create snapshots instantaneously, and they're point in time and they're writable, right? These snapshots, they're just volumes that share data blocks with the parent volume. Which means, unlike our accelerated snapshots approach with EBS, where we had to provision separate storage, we didn't really have to do that here, right? And the storage savings have been really significant. And not only that, it's also very fast, instantaneous, right? What we also realized is, because the data blocks are shared with the parent, it's really important to manage performance. So the workloads that are running on cloned volumes can impact performance on parent volumes. Thankfully, NetApp has quality of service or QoS feature. So we managed to use it and implement throughput ceiling on the cloned volumes, right? In practice, we did notice that the throughput ceiling, can sometimes the workloads can exceed slightly, depending 5 to 10%. So once you tune it, and once we are good with it, we guarantee that the performance of the parent volumes is not affected, and we're good there. So in a nutshell, using all these features, right, we managed to achieve 53% storage efficiencies. We could save our storage cost by 46%, and our platform refresh performance improved 5-fold. And that was really, really good. At this point, I would like to extend my sincere thanks to the entire database group who worked tirelessly to make this happen. Special mention to Matt Brasi, Fatima, Chandra, and Andy for their unwavering support throughout the implementation.
That's wonderful. I'm curious, we have maybe a few more minutes, but one thing we talked about today is actually that migration process and how that can sometimes be a challenge for customers. Can you tell us in just a few minutes, I know we're coming towards the end of the session, but what was your migration journey like?
Well, our migration journey was pretty simple. We used Enterprise Edition, so we had always on. We just created another always on replica, and then we're set. So, we had a relatively simple migration strategy. I think we spent most of our time in making sure that the performance demands are met, and we don't run into the noise and hybrid problem.
Yeah. And the QoS policies is something that's interesting. It's a detail of ONTAP ecosystem, but it's something that a lot of our customers are starting to explore. Any tips or recommendations for customers or how you manage your QoS exploration?
Right. So when we started exploring QoS, NetApp actually supports floor as well as ceiling, but I think FSX supports only ceiling at this point in time, but it worked well for us. So we set throughput ceiling on the clone volumes, and then that's when I mentioned that we noticed that sometimes when we have more workloads on the client volumes, on the clone volumes, we can breach the throughput ceiling, and that burst can be about 10 to 30% depending on the workloads, right? So that's why, if we are using QoS policies, I think it's really important to run your workloads and make sure that your volumes are provisioned appropriately. I think that would be my recommendation if you start using QoS policies. Otherwise, it's pretty straightforward.
For sure. I got a good example of how some of those like-for-like capabilities within the NetApp ecosystem can help make that migration journey easier and help do things like ensuring high performance. Last question for you, I know we're all coming up on time, is what's next for Arcesium?
Well, at Arcesium, we believe the best way to grow our business is to provide the best possible experience for our customers. We always strive to get better at what we do, and improve our services and offerings. From an FSXN standpoint, we want to explore capacity pool storage, and we definitely look forward to your continued collaboration.
Awesome. Well, it's been wonderful having you here. Thank you for joining. The audience, thank you all for joining. I'm not sure we'll have time for Q&A, but we're happy to hang out up on stage afterwards if you have any questions. Thanks again, everyone, for joining us.
Thanks again.